Hello all. So we're live once again today, and today we're going to look at something very different from what we were used to look at. So instead of going on with the documentation today, we are going to look at Firebase Performance Monitoring and basically why it is useful first of all, and then we will see some missing implementation in this public open source code, which basically groups all the Firebase implementations, but for Kotlin multi-platform. So basically, this is this can be used in your Kotlin multi-platform project, this package, and it might be useful also for you if you have a Kotlin multi-platform app. So without further ado, let's start reading what Firebase Performance Monitoring is. So it basically allows you to get insights on your app performance. And for example, you can collect performance data from your app to review and analyze that data in Firebase console. And performance monitoring helps you to understand in real time where the performance of your app can be improved and what you can fix. So, for example, the key capabilities of this SDK are that you can measure app startup time, HTTP network requests, and even more. So you can also gain insights into situations where app performance could be improved, and you can use your own metrics, your own attributes, and whatever. And you can also customize monitoring for your app. You can instrument custom code traces. Yeah, that's what we just said, to capture your app's performance in specific situations. For example, when you load a certain screen or display a new interactive feature. And yeah, you could count traces. Yeah, you could use custom code traces to count events that you define. And you can also identify significant changes in app performance, like, as you see here, network outages, or something that is vital for your app success. Okay, so how does it work? Firebase automatically starts collecting data for most processes. For example, app startup time, screen rendering for Apple and mobile apps, and Android apps, page loading for web apps, and network requests for all types of apps. Actually, this only works, I think, if you use certain plugins and not all the plugins available. And yeah, you have here implementation path. It works for Android, Apple, web, and Flutter. Of course, you need to use the SDK. And what is missing in the Firebase Kotlin SDK is the implementation for Apple, Android, and web for most of the interfaces given by Firebase Performance. So, for example, I want to show you something. So Firebase, here the SDK groups many of the Firebase services, like, for example, analytics, authentication, and so on, real-time database. Some of them are already partially or totally, or most of it is implemented. And in performance, we have only 10%, it says here. But in fact, if you take a look here, we will see it actually in Android Studio, which is a little bit better to navigate. we have Firebase Perf, so Firebase Performance class, and here Kotlin multi-platform code is divided into different packages for different directories or modules, how you want to call them. And you have like common main, which is for shared code. Then you have iOS main and Apple main, and then you have JVM main and so on. So JS main. And basically, if we look at the Kotlin multi-platform documentation, what we can see is that Kotlin has multi-platform support, and of course it reduces time to maintain different code on different platforms. Sorry, the similar code, I would say, on different platforms. And so as you see here, Kotlin allows you to share code across different platforms, whether it's mobile, web, or desktop. And the platform to which the code is compiled are defined by the list of targets. So basically, if we look directly in our, let me check, in our Gradle script. Okay, here we are in Android view. That was why. We have to switch to project view, which is a little bit more detailed. And here we can look at our Gradle. And in our Gradle, we can see the defined platform targets. So inside this script, we can see that we have Android target. Then we can see we have JVM target, and we also have iOS, all the ARM x64 simulator. Then we have JS, so we have JavaScript. And are we missing something? I don't think so. So basically, we can code for JS, iOS main, Android main. Probably today and also JVM main, but probably today we will only look at our Android code, which is going to be easier for me to code live. And as you see here, however, on the JVM, or probably also on the JS, let's see. No, the JS is kind of, there's some implementation. So the JVM is not implemented because probably it's not even possible to implement that. Because yeah, the JS should be for web. I think JVM cannot actually be implemented. I don't know why they have specified this, but however, what we care about most today is Android. So, okay. So we'll look at this now. So let's keep back here and let's have some basic knowledge of Kotlin multi-platform. Use code sharing mechanism, share code on platforms, dependencies. Okay, here we have a menu. And if we go to the basics of Kotlin multi-platform structure, we can see that with Kotlin multi-platform, yeah, you can share code, blah, blah, blah. Common code is the code shared across different platforms, and you can call these from the Android or iOS specific code. So the Kotlin compiler gets the source code as input and produces a set of platform-specific binaries as a result. When compiling multi-platform projects, it can produce multiple binaries for the same code. For example, the compiler can produce the JVM class files and native executable files for the same Kotlin file. Okay, not every piece of Kotlin code can be compiled on a platform. The Kotlin compiler prevents you from using platform-specific functions or classes in your common code since this can be compiled to different platforms. So, for example, you can see here that Java IO file is it's a part of the JDK, while common code is compiled to native code, whereas the JDK classes are not available. So you cannot use this because it's specific for desktop JDK platform. In common code, you can use Kotlin multi-platform libraries. These libraries provide a common API that can be implemented differently on different platforms. That's what we're doing with Kotlin. That's what you will see that this package is doing. Okay, so coroutines is a Kotlin multi-platform library that supports all targets, but it also has a platform-specific part that converts Kotlin coroutines, concurrent primitives, to JDK concurrent primitives like coroutine dispatchers as executor, blah blah blah. The targets, as we said, they can be declared JVM target that corresponds to 64-bit iPhones, and so on. So instead of reading this, I would suggest to just go on with the most important concept, which is expect and natural declarations. Expected and natural declarations allow you to access platform-specific APIs from Kotlin multi-platform modules. You can provide a platform-agnostic APIs in the common code. So to define expected and actual declaration for these rules, in the common source set declare a standard Kotlin constructor. It can be a function, a property, class, interface, enumeration, whatever, or annotation. And then you can mark this with expect keyword, and this is your expected declarations. These can be used in the common code, but shouldn't include an implementation. Instead, the platform-specific code provides the implementation. So basically, what you can see here is that in common main, we have our Firebase Performance object, which is a part of a class. Yeah, so this is a value, which is an instance of a class, public spec class, as you see here. And this is our class that has 1, 2, 3 methods with functions. Then you have also public class, okay, expect open class Firebase Performance exception, which inherits from Firebase exception. Okay. This is from Firebase app actually module. It's interesting. And what you can notice also is that we also have metrics here, which is another class, trace. So our trace class has start, stop, get long metric, increment metric, output metric. So let's just jump over to the Android example here. So yeah, you have implementation. So if you want to use performance SDK, you need to do all of this, and you have to go run simple app. Let me open these. What I would like to show you is a quick example of how you can start and stop a trace. So basically a trace is something that starts at a certain period of time and ends at another point. And inside the trace, you can put some like metrics or arguments that you want to capture. So that, as we said, can be useful to check if network is loading fast, um, if you want to log something like and push it to the Firebase console for analysis and so on. So here we only have start stop, get long metric, increment metric, and put metric. And this is part of our command main. What we want to do is to have the missing functions here, because there are some more missing function, and we think we can take them from Firebase Performance SDK documentation. Why did I close it? I have to go back. Oh yeah, over here, Android. I want to know where I can find the APIs. Firebase Performance SDK APIs. Just give me a second. Notation. Maybe if we click here, yeah. So we should be in the proper place now. Okay, so we have, yeah, as you see, we have a class trace, which is this one, public trace implements per syllable. And this is, yeah, for Android, of course. And this one has all these classes like try to parcel, stop, start, remove attribute, put metric, put attribute, increment metric, and so on, which are missing on our multi-platform code because we don't have all of them. So let's get side by side and let's recall all of them. So public fields, public methods. So what I'm going to do is I'm going to say public fun describe contents. And we can have public fun get attributes. And this has to be an attribute string. Let's just put this comment for now. Then, so we have describe content, get attribute, get attributes. And this will give all the attributes. But it should return a map of strings. Get attribute instead should return a nullable string. Yeah, so since they're nullable, I think that should be this is nullable, so it should be like this. We'll see this later on, but that's how it should be. Get long metric. You see, we have it here. Yeah, we could put them in the same order of the documentation. So we might have describe, yeah, start and stop, we'll leave them there. Get attribute, get attributes, get long metric, and we have it. You see metric name, string, and returns a long, and we're good. Then we have increment metric, and we have to give metric name and long increment by. Okay, we have it. Then we have put attribute. We don't have this one here. Public fun, put attribute, string attribute, string value string, non-null. Okay, they are good. Then we have put remove attribute. Sorry. Put attribute and put metric. And this one is metric name string long, and then yeah, sorry, value long. Okay, we already have that one. Then so we have put attribute, put metric, public fun, remove attributes, attribute string. Then we have start and stop. We'll go right here. And we have write to parcel, but since parcel is something from Android, I don't think we can implement this in multi-platform. So I would suggest sticking out of this one for now. So describe contents. Now we would have to place all the how to say documentation inside our methods, but we can do this later on. Describes the kinds of special objects contained in this parcelable marshaled representation. So yeah, this should return here as well. I don't know what's the use for that one, but what we care about is to implement put attribute, remove attribute, because this will be the most useful methods actually. And then get attribute and get attributes. These are the most important methods of the trace class, I believe. Okay. Then yeah, we have some extension functions. But how we will see this later. These are constants, so they cannot be changed. I think we should be good with this trace class now. And what else? So yeah, we have implemented the class on common main. And now we go to Android main. And you will see that we need to add missing implementations for our Android code. And the same will be for our trace in iOS. But first, let's go on with Android. So here they already had provided some implementation for Android trace. As you can see here, what they did is they have created this extension property treat.android that is basically returning the Android trace, which is part of the Firebase Performance SDK from Google. So this is the implementation from Google, Android trace. And they're passing it inside the constructor of trace. So when trace is created, you are passing the Android trace object inside it, the class implementation. And here on, basically what they're doing is on each get attributes. Yeah, actual get attributes and get attribute, put attribute and remove attribute were actually implemented in a specific code, but they don't have the actual because they're not part of the global common interface. So as you see, yeah, just one mention. I stopped reading the documentation here, but what you care about is that in common code, you have to use the expect keyword if you want to say, hey, this function will be defined on specific code. And in specific code, you have to use the actual keyword to, let's say, override that function in specific code. So that's what we're doing also here. As you see, we are providing an implementation for trace, which is Android specific. And we have added get attributes by default because we had them in our they had already implemented it, but there was something missing, and here we have to instead return yeah, actually we could do it with the equal, and we can say Android get describe contents. Okay, so we're providing a specific implementation for our Android code. As you can see here, actually it's always returning 0. So this is kind of useless to expose it anyway, but I don't know. I don't know what's the purpose of this. Anyway, we are implementing the whole interface, so we have to do that as well. If we go to iOS now, let's see, add missing members. So here we were actually missing some other stuff. And this comes from fear trace. So unfortunately, I don't have Mac right now, but we can have a look on the internet if we can find some API for that. Fair trace. Let's see. So our code for trace is iOS start. Okay, so this is our void start function and our void stop. Okay, over here. And then what we're missing is value int metric. So what I see here is that the free taste could be nullable, which is also strange because I think in Android it's not nullable. So the free trace returned could be nullable. Anyway, we would have to look at that, but what we have to do here is implement these missing methods. And let's see if we find the scribe contents here. So we don't find it, which means that actually we could remove this useless method. Let's see if we have get attribute. Maybe, yeah, I think that for this one, we need a Mac in order to make sure that we code this properly. I didn't think about this, but it would be better to have macOS here. I want to see something anyway. Why were these get attributes? Yeah, because they are in the test, that's why. So test get attributes is here because they are making a test with Android implemented test. This is very easy to look at. So we have our class Android trace test, which creates a Firebase Performance instance. And this instance is from specific code. So as you see, it's actual class. And it will initialize Firebase. So before every test, it will do this. And it will create a value app and assign performance, Firebase.performance app. And this will be the same probably as in the official docs. Let's check it again. Reference. Maybe here. Monitoring. Let's go to Android again. Code simple. Yeah, because here it's not very meaningful. The documentation is not that good, but anyway, this is to initialize the performance SDK. And then when you have initialized it, you can call something like new trace. Okay, and this is also to initialize the Firebase backend, Firebase instance. So for each app, delete. This will deletes the Firebase app and all its data. and calls to this Firebase app instance will throw once it has been called. Okay. So here they made a test for put, get, and get attributes. Let's see the put test. So what they did here was they have created a new trace called the test put attribute. They start the trace, they put the attribute inside, and so the test attribute will be this, and the value of it will be this one. And they assert that the trace get attribute with the same key that you have here, is going to be equal to the expected value. So that's the kind of test that they are doing. All right. And then here, it's going to be the same. So as you see, we get the attribute in this case. So we put the attribute, we get the attribute. It's actually the same test. Yeah, it's not very meaningful here, I would say, but get and put are the same test. So I mean, how would you do it differently? Then you have test get attributes. So we use multiple values, and for each of them, we create a different attribute with a different value in it. And then we get all the attributes, and we expect the size to be 3. And on each of these attributes, we want to check if entry key last equals entry value last. So is this test correct? So get attributes returns a map of strings. Oh, they're doing last character, so this is probably a wrong test. Because you should check if the values because the values, this is not a very good test. You should probably check if the if the keys are equal to the keys that you have put inside, and if the values are equal to the values you're placing inside. So I think they should be so I will put just a mention here for maybe when I have some time. And one thing that we have missed is we did not see the Firebase Performance interface, if it has something that we did not take into account. So this will give get instance, which returns a singleton of Firebase Performance, but we cannot do that in common code because this class is specific for Android. Yeah, it makes no sense. Is performance collection enabled? And I think we have this one right there. Then we have a new HTTP metric. I think this one is missing. So we can call it public. Let's put them side by side as we did before. Public. Actual fun new HTTP metric. And here we have URL string. And then we have HTTP method, which is also string, not now. Both are not now, and we're good to go. So here we have them both URL and string URL. But since URL in this case is Android specific, we cannot implement this one, but we can stick to this one and it's enough, I think. And then we have new trace. What did I do wrong here? Add function body. Oh, this is from actual. Oh, sorry, guys. So we have to go on our common code and performance. Here we go. So this is our expect. Okay. Our expect. So we need to have get instance is performance collection enabled. We just put it here. Then we have new HTTP metric, which we just did. We have new trace. Oops. And we have set performance collection enabled. We have start trace. What? Why do we have start? Creates a trace object with a given name and start the trace. Aha, okay, that's just basically it's both new trace and start trace. Okay, well, we have it, so start trace name range. Now public actual fun. Yeah, we don't need this. But here we're in common code, right? Let's double check. Yeah, common code. So if we go to our if you do Control Alt B, you will get all the implementations of this interface. For example, of course, we want to go to Android. Should be this one. And here now it's saying add missing members. We can do that. Yeah, we haven't checked if this one returns a trace. So we did a mistake here. It should also return trace. And the new trace, this one does not. Yeah, it returns HTTP metric. So we have to add this as well here. And HTTP metric
does not exist because it's not implemented as well, and we have to do it. It's under metrics. So we go here, and now we can check what's missing. So this, as we said, has to be a public spec class. Add missing. Yeah, before adding the missing implementations, we just go here. Oh. It has all this stuff, but it's not why this metric does not inherit from trace. This is very strange. I'd like to see it in code, but it's how do you do that? HTTP metric. We cannot find it. I think this is not inheriting from trace. So we have to redeclare all the methods, like get attribute. Let's go very quickly. So fun get attribute. This should return a string. Public, okay. Public fun get attribute. This should return a method string. Then we have put attributes, which should return attribute value string, put attribute, remove attributes. This should be used to set the HTTP response code. Set request payload size, and this is long bytes. So bytes and long. Then we have public fun that response content type, and this is going to be a content type string. Then we have set response payload size, public fun, and we have bytes long. Then we have public fun start, and this is void, and then we have public fun stop, and this is also void. Okay. And that's done.
Then here we can import the HTTP metric class. And here we need to add all the missing implementations. Let me double check which ones were implemented at the start of this. So I'm missing so we have JS, JVM, iOS, and Android. Let's add them. Add everything. And records with that one. Public expect. And now we can add oops. I wanted to go here, here, here. Now we can add our missing implementations. Oh, that's bad. We have to add like the public manually. Perfect. Done. Now for these, we should return something. So let's create our HTTP metric as they've done here. So this is not part of the class, it's part of the file. And here we have to say HTTP metric Android. Oh, what I want to see here is instead of having a trace, we have a metric. This implements Firebase Performance attributable. So they're not, yeah, surely we know now that HTTP metric does not inherit from trace. They are two separate things. And now we should just call the Android dot. Yeah, here of course we have to pass it as they were doing in previously. Yeah, Android trace. Let's do as they've done here, which is package. Let me double check. Import this as HTTP metric Android, and it should be the same. Android. We'll go here. So we're doing the same stuff. Recursive property accessor. Get why trace. Wait, I don't know why it's saying that. So now here we also pass our kernel Android, and now we say get attribute. We're missing string. Crap. Inside here. Let's get back to our common. Get attribute returns string.
but once also string attribute. And string, and then we have to pass that. Okay, it's nullable. It's because entire it. And let's do the same here. Return Android, get attributes. Whew. Let's return Java util map. Okay, we should be good to go like this. Let me double check what I've done in trace. Not here, but here. Yeah, exactly the same. Perfect. Yeah, we can do more concise code like this, and also like this. Then we can have put attribute, remove attribute. They're going to be basically the same as here, so I just copy them to save some time. Then we have set HTTP response code. So in this case, we just need to call found trace. Oh, I was wrong here. I'm doing some mistakes here. So com is Android metric. This should be Android metric. Okay, perfect. Now we're good. Response code, Android. Set request payload size, bytes. Then here we do Android set response content type, and then we do Android set response payload size, bytes, and then we do Android start, Android stop, and we're going to go Android dot. Yeah, we also have these two methods. Why didn't I see them in the docs? Make request complete and make request response start. There's also trace. So, let's see, make mark, not make, mark request. It's not here. They do not have updated docs. I think this is missing. I want to add it here to do. So these are missing, but we do not implement them yet. So our HTTP metric Android should be good now. Trace should be good. What are we missing? Third session. Here we're missing and missing. Yeah, we're missing. Let's remove them and add them again. This and that one. So new metric should be Android dot. Oh, should be HTTP metric Android new HTTP metric URL and HTTP method. Here we could also pass the Android URL just for safety, but it's not really needed. And to start the trace, we have to do Android new trace name, or actually, let me double check. So this start trace returns a trace. That also starts it. Oh, I mean the wrong package. Firebase Performance. So should be Android dot. I mean these docs are not updated because I don't find this method here. It should be here. Anyway, I think you can do just new trace and then start it. We don't really care about one boilerplate method in this. In our docs. So we're good to go now. And no actual. Why is it saying that Firebase performance exception has no corresponding special exception declaration? So if I go to common, I do have it here.
Firebase performance exception. I think this is kind of some issue with the IDE not recognizing that all is good. I think that's it. Let's just validate this code with ChatGPT. Your code is almost correct. Yeah, so it should be good because we have the expect class in common main, open class. Yeah, should be good. Was working before, probably it's working now as well. So we have implemented, let's recap all of it. We have implemented HTTP metric just by calling the Android HTTP metric, which is the specific code implementation and all of its interfaces. Then we have, okay, here we have to add attribute. Nope. Just need to get in this file, add missing members. Good. And same goes here, here. These are the HTTP metric classes. Here in our performance KT code, we have created a new HTTP metric class function, sorry, that returns the metric and runs a new metric as well. Then, what else have we done? Yeah, we have specified new metric here and new trace here. Well, yeah, we just moved new trace, sorry, from above to below. Trace for code clarity. Then we have, yeah, we have seen that this is probably wrong. This test is probably wrong. And we have added all the actual here because they were missing. Actually, they were not in the Android, not Android, but the trace global interface was not including them. And yeah, we've seen that this describe contents is actually useless. So we could remove it from trace. Let's remove it from trace. Common main. Describe contents. Okay. And then we have to remove it from all the other expect common describe content iOS. Okay. So now what are we missing? Still probably trace. Yeah, here it's missing actual. Well, get attributes was not here. Maybe we can implement this. Should return strings. So retro. We're doing retro ps.get attributes. This is returning a map of strings. Perfect. So we have also implemented the missing get attributes here. So explicit API mode needs to implement that. So we should good with the JS implementation also. We're missing the iOS. And let's see JVM. Yeah. So let's go step by step. In JS, we also have not implemented this, but it should look very similar to all of that. So we try to implement the JS. I didn't think we would go that far, but we can. Here we have to place HTTP metric performance instead of doing this. Performance trace. HTTP metric. There we go. Just a second, because I'm confusing myself. External. I'm not really sure what these externals are. So basically we have a trace, and this trace uses performance trace. Which is an interface, and our actual trace right here. Our actual trace public external func I'm not sure what is an external function. Let's look. Okay, so it's typically in JavaScript or native C or C++ code or other specific platform-specific code. So you are declaring a function trace in Kotlin, but you're not providing its implementation. Instead, the actual implementation is expected to come from somewhere else, depending on the platform. So for example, this way you're calling an alert message. Okay, so starting to understand a little bit, but so these are coming from JavaScript. So we want to look at JavaScript code. So yeah, we still have. Let's just take a little break. Then we recap what we have done with Android. If we have all the implementation done in Android, and then we see if we have time to go on or not. Because I'm a little bit tired and I don't want the stream to be too long. So let's make a little break. So we're back. All right. So what we did so far is we have implemented HTTP metric for Android. We have finished the implementation for trees, and right, we didn't know that we have this specific like update session function. An update app, push attribute. There are some specific OS functions. Yeah, specific Android functions. And we have added a new HTTP metric here, and that's it. So that's all for Android main for the moment. We could create the new tests here. Unit tests. See what I've done here? Nothing. So yeah, they're using instrumented test. Here, just let's type a comment to new test for functions. So we have to add them. Then, so we have our new HTTP metric, and we have added some things to performance and trace. So common code is good. Wait, this does basically the same as, yeah, it should do the same as the other tests, or almost the same. And very good. So we can add new tests here as well. And what else? So we have iOS main. We could not implement this because we don't have iOS, and would be better to run this on iOS. So I will do it because I have an iOS, but not at the moment. And this is good. We also have iOS tests. Oh, they have not implemented these. That's good. We have performance SDK for JavaScript, and we have seen that external means that it's externally implemented, like in it's externally implemented, for example, in JavaScript. Okay, now here I see that here it's specifying JS module Firebase Performance. Let me double check something here. JS. Basically, use common JS. Here it's probably specifying to use Chrome headless browser for test tasks, but I thought we would find something regarding the external, but we did not. So now that we have that, performance trace is inherited. Okay, from HTTP metric because it's wrong, but we have to change it yet. But it's inherited from trace as well. Because this is the external interface coming from JavaScript, and we need to create HTTP metric as well. So in order to do so, we need to understand where these methods are coming from to make it properly done. And this means that we have to search for performance monitoring. If I write web, Firebase just performance. So this will probably import as there. And let's see, performance monitoring for web. API reference, there we go. We have found it. So, performance package, the Firebase Performance Package Web SDK. The SDK does not work in a Node.js environment. Oh, interesting. So we have Firebase for performance, performance settings, and performance trace. These are the interfaces. And boys, where is the HTTP trace? Don't tell me it's not implemented here. So performance settings, data collection, instrumentation enabled is here. We have performance trace, interface. Well, I don't understand whether this is nullable or not. Okay, property is optional. It may or may not be present on the object. Okay, so we'll leave it like that because I'm not sure about it. So the trace is implemented, I believe. We have get attribute, attributes, metric, increment metric, put attribute, put metric, record, attribute metric, remove attribute sets up. And we don't have record. Okay, so we don't have record. We just type this here. And okay, so the implementation here should be good. This one should be good. And get performance. What is performance? Is an app, Firebase app defined externally. Okay, it should be good as well. Increment metric. I want to check something here. On the increment metric, num is integer defined externally. So I think this should be Okay. I don't know. I mean, this implementation should be fine here. And I don't think we have HTTP metric for JS. I mean, can return HTTP metric, but it's actually useless. Let's see if we can merge them. Something different from to do. Uh, well, I think we can go with error not supporting JS. Okay. And here, 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 and here. So basically it's not supported here, and I also doubt it's supported in JVM. But we'll double check now. So I don't even think that JVM let's do a stupid question. What's the difference between using JVM in Kotlin MM? So JVM, Java Virtual Machine, Android desktop, server side. Aha, so it could be server side. JS is web Node.js. But Firebase does not have an implementation for desktop. At least Firebase Performance does not have that. So I think that here we will always have error. as these are not implemented and not supported in JVM. Tack, 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 tack. Good. So everything over here in HTTP metric is not going to be supported. We could probably also delete the file and there's about it. Not supported, not supported. Okay. So what are we missing now? Let's see our to-dos. Maybe in our directory or module. To-dos. We miss iOS implementation and we miss tests. So here we should probably add the missing tests. SR4, SR2, okay. This is implemented. New trace is implemented. We are missing new HTTP metric. Implementation. So let me double check here. What's the issue? Let me try to run the tests like this. Let's see what happens. Emulator, okay, we need. Yeah, I was running, sorry. Run compiler. Think I need some explanation on how to run these tests, but let's see if ChatGPT can give it to us. Okay, we should be able to run them with this command. Let's see. So we've had an issue. Not found your root project. Let me double check. I did a typo, maybe. Let's run it again. Probably I've had a typo. Okay, so the tests are successful now. Skipped? Why skipped? Create test. Let me just check. Um, hmm. Says check for ignore annotations. I see them ignore annotations here. Ignore for Android unit test. What does this mean? So I would propose to do like this. We end up here with live stream today. We have implemented almost everything we could do for Firebase. We need to do some tests and we need to do the iOS part. So I will run this next time on iOS and implement the missing functions, and then I will come back to you also with the implemented tests so that you can view how I've finished the implementation for Firebase share prep, Firebase monitoring on the SDK from Git Live, which I thank a lot since they have created this very interesting project that allows you to implement any Firebase function, any Firebase module that you wish to implement on KMM. So thank you very much to them, and also thank you very much for watching. If you find this interesting, please like, subscribe, and come back to the newer live stream when we will start live stream again. Thank you guys. Bye.